Enums and data. Enums in Rust are fundamentally different from enums in most other languages. In C or Java, an enum is basically just a name integer. In Rust, enums are what's called algebraic data types. Each variant can carry its own data. Enums are more than labels. Each variant can hold different types, a tuple of values, a name struct, or nothing at all. One enum can represent multiple completely different shapes of data. Protocol and state machine. This is what makes enums perfect for modeling systems where the valid data depends on the current state. A blockchain transaction that's pending has a different relevant fields than one that's confirmed. An enum lets you encode that at the type level. Exhaustive handling. When you match on an enum, the compiler forces you to handle every possible variant. You literally cannot forget a case. That eliminates an entire class of bugs at compile time. Look at what this single enum expresses. A transfer event that carries three named fields: from, to, and amount. So that is the sender, the recipient, and the amount. It also has a meet event that carries an amount, I28. A burn event also just carries an amount. And posed carries no data at all. It's pure signal. In C, you need a union of a type tag and hope you get it right. In Rust, the type system handles all of that for you. Each variant is self-describing. Pro tip: Rust enums are algebraic data types. They carry different shapes of data in each variant, making them far more powerful than simple C-style enums. Now, let's talk about one of the most impactful decisions Rust made. There is no null. Instead, Rust has options. It's defined as enum. You can see in the comment enum option T, some T, or none. So this is just an enum with two variants. Some T wraps a value and none represents the absence of a value. Let's see it in action. Clear this. So we're just going to copy the code and I'm going to explain. So we have a function here, function find balance. It takes an address of type string, slice, and it returns an option of type I128. So itada is going to return some or else, none. And then here we have the main function. So let's start with find balance. So find balance might find an encounter or it might not in this case. So instead of returning a magic value like -1 or -2 or risking a null pointer, it returns option of type 128. The caller is forced by the type system to deal with the possibility of num. And when we go to the main, we see we created a variable, let b, and then we call the function find balance abc. So this is just going to call this function. So if our string slice is gabc, then sum is a value that's going to be shown, that's going to be returned, or else none. And we also have unwrap or 0. So unwrap or 0 extracts the value that we're getting from b and it falls back to 0 if it's none. So if in a case that we're actually on none, then it's going to fall back on 0. So map here applies a transformation only if the value is sum. If it is none, it stays none. And at the end print line, we have a function called, a method called isSum. So this checks which variant it is. So if it is sum, then we're going to print true, but if it is none, it's going to print false. So let's run this code. So as expected, we get this value and true. Let's actually make this number smaller. So we get it, and we get a warning here because hello world generated one warning. We didn't use this variable here. So let's actually use our variable. So this will basically double our v if v is indeed sum. So we're going to print doubled unwrap. So it's going to print out our number, but if it's none, it's going to print a 0. So that's basically what it does. Let's run the code again, and voila, because we've doubled it to 1,000. What else can we do here? Now let's assume now we change this to GAB. Then we're going to find balance, and this is our string that we put in our parameter, but that's address equal GABC. In this case, no, because it's GAB. Then we're going to have none. That's going to be returned, and basically here you're gonna print B unwrap all. So B is going to so the value is going to be printed out is going to be 0 because it's going to default to 0, and doubling will not do anything, will just stay 0. And here b.isSum will be false, and here will also be 0. So let's run it. So we got these values as expected. Now let's cover for loops, the geometric way to iterate in Rust. So there's two ways of doing that. There's for I in 0 to 5, print I. So this is going to print I starting at 0 up to but not including 5. So the I is going to be 0, 1, 2, 3, 4. But if you use the for this way, for I in 0 to equal 5, in this case you include 5. So it's going to be 0, 1, 2, 3, 4, 5. And let's see it in action. So we have for I in 0 to 5, we're going to print let's just print So let's run it. You can see here we print 0, 1, 2, 3, 4. We can also do it a different way. We print line. Let's try this. So it prints 0, 1, 2, 3, 4. It does not include 5. But now if we change this to we add an equal here, then it's going to include 5. So that's basically how we use loop in Rust. Now let's do a different one. Let's use vectors. Like, how do we loop in vectors? So let's create a vector. So let address equal vec, and we have g something, and we have gd something. So we have these two addresses. Now here we're going to be doing something a little bit different. We're going to use for address in our vector we're going to print the address. Let's run it and see if we're going to see an error. So let's run this. So here oh, I made a mistake here. Forgot to, yeah. So this works, but in best practice, it's best not to do it this way, because once the loops runs over address, it will no longer be usable after running the loop. So the best practice is to borrow it, so that you'll still be able to have access to this vector. So that's the best way to do that. And now let's run. You can also use enumerate like this. So dot enumerate gives you the index alongside the value distracted right in the for loop pattern. So let's run this. Let's see 0, it prints out the index and the value. Now let's break this code Let's remove this and remove this, and here let's print. Let's try to get a value from this vector. So we're going to be getting the address. Let's get the second value. Let's try to get the second value. I want to, based on what I've said in a few minutes ago, what do you think is going to be printed out when I run this code? I want you to think a little bit. Okay, let's run the code. So let me actually clear this so we can see all the errors. Borrow of moved. We see these moved occurred because address is type vec, which does not implement the copy trait. So we did not copy, and we've used it up on our for loop, so you no longer have access to it. So that's why we needed to copy, so we don't have this problem. And now it works. Now let's move on to something new. Match, the decision engine. Match is the heart of Rust control flow. Think of it as a switch statement that's exhaustive, that can destructure data, and that's an expression returning a value. 3 things to know. Exhaustive by default. The compiler forces you to handle every possible case. Miss a variant and it won't compile. This eliminates the entire category of I forgot to handle that case bug. Second, pattern matching and destructuring. You can match against literal values, use the underscore wildcard, and unpack complex data, structs, enums, tuples, all in a single step. Third, ranges and match guards. You can use range syntax like 1 to 10, 1 to equal 10 to match a span of value. You can also add a guard, an extra boolean condition to branch with if. So we're going to see it in action. Let's get to it. So we have the following code. Describe, which returns a static string. So now we have the n, which is what we're going to put in our parameter. So n is of type i32, so basically a number. It can be 5, it can be 2, whatever it is, whatever number, but we need to have a number of type i32 in the parameter. So if that n matches with 0, then we're going to be returning this test 0. If it's 1, 2, including 9, then it's single digit. If it's 10 up to including 99, 2 digit. And the rest, so the rest of the case, we're going to print out large. So this catches everything else. So we have 1 here, we have 5. Let's run. And as we expected, single digit. And if you go into 84, we know that this is not the first case, it's not the second case, but it's the third case. As expected, we have 2 digits. So that's how we use match. The match guard syntax is pattern if condition. Here we bind the value to A and then add an extra condition. Like here, if A is less than 0, invalid. This lets you express complex logic cleanly without nesting. Here's where enums and match come together beautifully. Remember our contract event enum, so let's use it. Each arm of the match destructures its variant data directly. For transfer, we unpacked all 3 name fields in one step. For mint and burn, we unpack the single tuple value. For post, there's nothing to unpack. The safety tip: match is exhaustive. If you add a new variant to contract event, later the compiler will force you to handle it here. This is the killer feature. Your match statement becomes guarantees that all states are handled forever. Let's look at some more advanced matching technique. You can also try it on your own. You can match on a tuple directly. Each arm specifies the expected combination of values. Underscore as a tuple element means I don't care what this is. Now looking at the isWeekends function, the matches macro is shorthand for a match that just returns true or false. Use it when you only need a Boolean result. And looking at the check ID function, the at that we're using here, the at operator is the binding operator. And at 1, 2 equal 100 means match a value in the range 1 to 100 and bind it to the name n, so I can use it in the arm body. The pro tip: the at operator lets you test a value against a pattern and bind it to a variable simultaneously. Match is powerful but verbose when you only care about one variant. Rust gives you 3 concise alternatives. If let single pattern match. Use it when you only care about one case and want to ignore everything else. It's sugar for match with one real arm. There's also why let loop until pattern fails. Run a loop as long as the pattern keeps matching. Perfect for draining a stack, consuming an iterator, or processing a queue until it's empty. Let else early exit for invalid input. This is available since Rust 1.65. It matches a pattern or immediately diverges, returns, breaks, or panics. This is how you write guard, because at the top of functions without creating deep nesting. If you ever seen arrow code, deeply nested ifs, let else is the cure. Here's a code example. Both match and if let do the same thing. The if let is just less to type when you don't need to handle the NaN case separately. The key concept: use if let when you only care about one pattern and want to ignore everything else. So let's run our code. So here we're printing three things. So 50 million. So the match and if let are doing the same thing. And here we also using if let sum b, if something exists, if there's a value equal balance, we print has balance and the value of the balance itself, else no balance. We also have the while let. This is an example. The stack, you have stack pop here, you have let mute, so we created a value, a mutable vector of the following value. So meaning that we can change the values in the vector. And here we have while let sum top equals stack.pop. Stack.pop removes and returns the last element as option I32, because remember we're using sum here. So while it returns sum, we unpack the value and use it. When the stack is empty, pop returns none. The pattern fails to match and the loop exits automatically. Note that the loop automatically stops when stack.pop returns none. No manual length check, no index variable. Clean and safe. Create a main function and attempt to do this and see it in action. Here we have an example of let else. At the very first line here, the second line, sorry, we have input dot strip prefix and we have a G here. So here we're returning an option as well because we have sum. So if the string starts with G, then it's a match. But if it does not start with G, then we get none. So we immediately execute the else block, which returns early. So if the pattern does not match the address is bound and we continue. I'm sorry, if it matches the address is bound and we continue. So the result of this is flat code, no nesting. The happy path stays at the top level of indentation and invalid input exit immediately. Let else is perfect for validation checks at the start of functions, eliminating deep nesting.